Lesson 2, Unit 2. Developing the schedule. The process to develop a schedule follows 4 steps. Define the sequence of all activities, estimate the duration of each activity, assign resources, and develop the schedule. This is an activity in which team members and some key stakeholders need to participate and provide their input. Their experience in past projects will help develop a schedule that is achievable and realistic. From all the activities in the WBS, you will need to identify the sequence in which they need to be organized. Each activity will follow one of the following types of dependencies. Mandatory means one activity must not start until another activity ends. For example, you cannot start the building of walls until the foundations have been completed. The next one is discretionary. The sequence of activities is flexible. And external, in which the sequence of activities depends on factors outside the control of the project. For example, a dependency that another project completes an activity and delivers an output the project will use. Once activities are identified by the type of dependencies, the next step is to define the relationships amongst the activities. There are 4 types of relationships. Finish to start. Activity B cannot start until activity A ends. This is the most common type of relationship. Start to start. Both activities start at the same time. Finish to finish. Both activities need to end at the same time. And start to finish. The end of activity B is dependent on the start of activity A. This type of relationship is seldom used. When building a schedule, you can add a column on the WBS table where you can identify the type of relationship. For example, for activity 2, it has a start to finish sequence with activity 1. This information will be used in a software application such as Microsoft Project that will develop the schedule and use the relationships on all activities to calculate the total duration of the project. The next step is to identify if there are any specific constraints to start or end an activity. There are 3 types of constraints. An activity must be completed no earlier than a specific date or later than a specific date. And the activity must be completed on a given date. With this information, you can now proceed to estimate the duration of each activity. There are 3 common types of techniques to estimate the duration of an activity. Analogous estimating is using the actual duration of a similar activity completed in a past project. Parametric estimating is estimating the duration of activity based on a rate or industry standard for productivity. And PERT estimating, or the program evaluation and review technique, uses a calculation to obtain a weighted average estimation using optimistic, most likely, and pessimistic estimates for various sources. Note that the estimates are based on the number of people assigned to complete an activity. Once you have an estimate for each activity, you can now enter the information on the schedule application, and it will calculate the duration of the project, taking in consideration the duration of each activity and the type of relationship dependencies. In the example chart, the project duration is estimated at 125 days. Depending on when the project starts, the result will show the estimate date for completing the project. Note that the duration of a project is not the sum of the duration of all activities. This is because some activities are run in parallel. Responsibilities are assigned depending on the availability of resources. Some activities will require resources to be 100%, while other activities will require various resources to be at a lower percentage. The table below shows an example of a project schedule with assigned resources identified with letters. Once all resources have been assigned, you need to verify that there are no resources allocated to more than 100% of their available time. Most scheduling software can calculate this information and identify overallocations. The chart shows an example of the use of resources in the project and how some resources are overallocated. The typical amount of work a person is assigned to a project on a month is 160 hours at 8 hours a day. If your schedule is showing that some team members have been assigned more than 160 hours per month, you will need to review the work assignments. The chart shows the time allocations of each team member over the life of a project. The lines go up and down, and you can see that for some team members, there are times where they have been assigned more work that they can do. Overallocation of resources is when you assign more work that can be done. When you assign less work that they can do, it is called under allocation of resources. This chart is useful to identify resources assignment discrepancies.